Usually a reboot will solve problems like that. Okay, let's look at C55. Solve the equations and inequalities below. Check your solutions if possible. Now, let's talk about A. It's important that you know how to deal with this. I'm going to make one up a little bit easier. How would I solve that?
You would add 1 to
Well,
the x.
actually, the very first thing you want to do is separate it into two inequalities. In other words, when you see an absolute value sign, that means that this is true. In other words, that thing without the absolute value sign is true. Or never change what's inside the absolute value sign. But on the second part, you have to reverse the sign and the sign. Okay? You with me? Blake?
Oh, yeah.
Okay. Now, if I were to solve each one, I get that or that.
Yeah.
And both of those work. If you plug these in, they both work. Okay? So both of these would be solutions to the inequality that I gave you. Now, we could use the same principle on problem A. There's only one thing to look for, and I've fallen for this before. If I say 5x plus 8 is greater than or equal to -4, that'd be the first part, or 5x plus 8 is less than or equal to +4, I will come up with some solutions. Correct? I'll come up with two different solutions.
Yeah.
However, notice that. No, excuse me. There's nothing wrong with that at all. Let's solve each of these equations. Solve the first one.
So then the first one, you would subtract 8 from both sides. And the 5x is greater than or equal to -12. So then x is greater than or equal to.
Now we solve the one on the right, and we get 5x is less than or equal to -4, which means x is less than or equal to -4/5. Okay?
Yeah.
And those can certainly be true as long as x is greater than -12/5 or less than -4/5. That will be a true statement.
Yeah.
So there's no trick solution on this one. However, it's important to understand that if I change that to an equal sign, now the way you would typically solve it would be 5x plus 8 equals -4, or 5x plus 8 equals +4. And I would solve both of them. What's going to be my problem? And you have to spot it, because you won't spot it by solving these equations. You will come up with x equals -12/5 or x equals -4/5. But neither of those are going to work. And you know why? because the absolute value of something can never be a negative number.
Yeah.
So that's impossible that could be true. And if you spot it immediately, then you don't have to go through all this math. And all that math doesn't really tell you anything. It doesn't give you the correct answer. Neither one of these work, even though you went all the trouble of figuring them out. The better way to solve this problem would be, if it was an equal sign, to recognize that it can't be equal. And when I first looked at it, I thought that that was the kind of problem it was. But it can be greater than. There's nothing wrong with being greater than or equal to a -4. The fact of the matter is that the absolute value of that is going to be a positive number or 0. It will never be a negative number. Okay? Can you see as I'm writing now?
Yeah, it's like a little bit delayed, but it's not too much.
All right. So let's look at B. B is important. There's a particular technique you have to use for B that is not obvious. And it's because it's an inequality. The first thing I'm going to do is factor that quadratic. Whenever you see a quadratic like this, it's almost always required that you factor it. Can you factor that?
It's gonna be x and then plus and minus. And then factors of, so then 4 and 5, and then the 5 goes with the plus, and then the
Beautiful. Beautiful. Okay. So now we have this, but we're not used to solving inequalities here. If that was equal to 0, then x would be equal to -5 or x would be equal to 4. And I'd be done. But when you have an inequality, you have to use what's called a line chart. Familiar with these?
Not really.
Well, let me introduce you to them if you're not. First step is to figure out critical points. Critical points are whatever makes that 0 or that 0. So what are my two critical points?
-5 and 4.
I put those on my line chart only. I don't put 0 on there. It's not a critical point. Now, I pick a number to the left of -5. Pick one.
-6.
Okay. What is this when x is -6? Is it positive or negative?
Negative.
So I put a little negative sign there. I don't really care that it's -6. I just care that it's negative. What is the second part when x is -6?
Negative 10.
So negative times negative is positive. What that tells me is that any number left of -5 produces a positive. Now pick a number between -5 and 4.
0.
What's the left when x is 0?
5.
Positive. That's all we need. What's the right when x is 0?
-4.
Positive times negative is negative. And what that tells you is that it's always negative between those two numbers. And if I pick a number to the right of 4, like 5, I get positive, positive. So what's my solution to this problem? You can now read it from the line chart. Where is that product less than 0?
From -5 to 4.
That's the answer. If you do interval notation, it's -5, comma 4. That's the solution. Or do you use interval notation?
No.
Oh, really? Okay.
Or actually,
So interval notation is if they ask me where that was positive, then my solution would be easier to read in interval notation. It's positive from minus infinity to minus 5 in union with, this is the beauty of interval notation, 4 to infinity. In other words, there are two intervals where this thing's greater than 0. And the best way to write them is using interval notation. Sometimes you get a solution that has 3 or 4 intervals. So if you use interval notation, you can write the solution all in one row. Another way, if you have not had interval notation and this problem, you want x greater than minus 5, less than 4. So you think that's the kind of answer that they're expecting?
Yeah.
Yeah. And that works fine for this problem because there is only one interval where it's less than 0.
Yeah.
All right. Let's look at the next one. C. What's the first thing we're going to do with C?
Ooh.
What are we looking at? What's that called? It's a quadratic. It's a quadratic because there's an x squared, there's an x, and there's a number. Now, the fact of the matter is that it's a quadratic whenever you have an x squared. But when you have an x squared and you have an x and you have a number, the first step is to put it all on one side, put the other side 0.
Yeah.
So that gives us this. Now, I want you to solve these. So, how are we going to solve this quadratic?
Would you square root it?
No, you're not going to be able to square root that. You can't take the square root of minus 6x. I mean, it doesn't advance the problem. You need to factor. Whenever you don't know what to do with a quadratic, first solution is factor.
Okay.
Okay? Now, I'm not sure that this will factor. If it doesn't factor, then I'm going to have to use the quadratic formula. But it's worth attending, it's worth giving 30 seconds to see if it'll factor. It's so much easier to factor it than it is to use the quadratic formula. So, what's the first step in factoring this?
On the first term.
Split up the 2x squared. And the only way to split that up is like that.
Yes, and x.
Put x and 2x, but that doesn't really matter. Fact is, those two numbers have to multiply to 2x squared.
Okay, so then it'd be minus and minus, and then it'd be 2. Wait, what?
Well,
oh yeah, and then it'd be 1 and 5.
If I put the 5 over there, then that immediately gets me up to 10x, and there's no way I'm getting back down to 6x. So I'm not putting my 5 there. Okay, it's true that it becomes a trial and error, but the only thing that can possibly work is the 5 there and the 1 there. What does that produce for a middle term? That produces minus 7x. So, I can't factor this. So what next? In other words, I've given it 15 seconds to see if I can factor it. And there's no way to factor it such that you can produce a middle term of minus 6x.
And the quadratic formula.
Okay. You know the general quadratic? That's where you always want to start. If you can always remember the general, then you're never going to have a problem. But you got to remember the general.
negative b plus or minus the square root of a b squared minus 4ac all over 2a.
Ah, I detected a little musical melody there. Somebody
Yeah,
taught you this with a song, didn't they?
yeah.
Can you tell me what it is?
It's just like you kind of say it with like a rhythm. That's it.
X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. See, I don't have the rhythm, but
It's like
I wish I
equals
did.
b
Um,
plus the square root of b squared minus 4ac all over 2a.
oh, all right. So let's plug it in. What's minus b?
So go back to the when b is 6 or negative b is 6 when x is 6 plus or minus the square root of negative 6 squared is 36 minus 4 times 2 times 5, and that's 8 times 5 is 40, and 36 minus 40, and x is equal to 6 plus or minus the square root of negative 4 all over 2a, when 2a is 4.
All right, so let me write that, what you said. So x is equal to 6 plus or
Plus
minus
negative 4,
square
negative
root
30 minus
of negative
4.
4, which is an imaginary number, all over 4. Now, can I simplify that?
No.
Actually, you can. First of all, let's deal with that negative, the radical of negative 4. What is that equal to? You've had imaginary numbers, clearly, otherwise they wouldn't be giving you this problem.
Oh man, this is a easy. Haven't had them since before spring break.
Okay,
Uh,
let me review. I'll make it real simple for you. When you have the radical of a negative number, always split it into that, because we know that that is I. And
yeah,
the square root of 4 is 2, so that's just 2i.
yeah.
Okay, so I can replace that square root of negative 4 with 2i. Now I can divide top and bottom by 2, giving me 3 plus or minus I all over 2. And that is a legitimate answer. That would certainly satisfy that problem. If they told you always put your answers in A plus BI format, what would this be?
Um,
In other words, the standard format for a complex number is this: A plus BI. If I'm going to give you a complex number, I want it to be in this format. Well,
then just
this
multiply,
isn't quite there.
then just multiply it by 2 and go back to 6 plus or minus 2i.
Well, how about we just split it up into two fractions? There's that fraction and there's that fraction.
So
So
3.
it's 3 halves plus or minus 1 half I. And there it is in A plus BI format. Whether they wanted it or in that format or not, I can't really tell by their question. But either this or this is the answer. Not this over here, because that can definitely be simplified.
Yeah.
They always want you to simplify it if it can be simplified. All right, how about number D? What's the first thing we're going to do on D?
You could multiply it all by 3 to get the
What's a better number to remember what your goal is on equations. Get rid of denominators, get rid of parentheses. How do I get rid of all three denominators in one step?
Multiply by 9.
Multiply by 9.
Yeah.
In other words, I'm going to multiply that whole thing by 9, and I'm going to multiply that whole thing by 9. And what happens is it turns it into an extremely easy equation to solve. In other words, I don't have any denominators anymore.
Yeah. So then you just subtract 5 from both sides. Then it's negative 3x is equal to negative 9, and then x is equal to 1.
I think it's that.
Oh, wait, I did that wrong.
Let's go back a step. I want to point something out to you. When I am solving a linear equation, the first question I have to ask myself is which side am I going to put the variable on? Am I going to put it on the left or the right? And the answer to that question is whichever side gives it a positive coefficient. So which side do I want to put the x on?
The left.
The right. If I leave it on the left, it's got a negative 3 coefficient. If I move it to the right, it's got a positive 3. Well, if I'm going to move the 3x to the right, then I got to move all the numbers to the left, and now I get that. And the only difference is, notice I don't have any negative numbers to deal with. And that's an advantage. People make mistakes when you give them negative numbers to deal with. They just do. So whenever you're answering that question, and there's always one point in an equation where you have to answer that question. Which side am I going to put the variable on? Which side am I going to put the number on? Put the variable on the side that will result in a positive coefficient. All right, let's look at this piecewise function. Now, when you see a piecewise function, I want you to always start right there, upper right domain. Okay? So what we have here is we have when x is greater than or equal to 0, I'm just going to put an imaginary dotted line in there. And the territory we're talking about is over here, correct?
Yeah.
Okay. And the lower function is x less than 0. So that territory is going to be over there. And that's the way I want you to think of these piecewise functions, is start with your domain. Now, if to the right of the y-axis, the function is 2 to the x, well, how do I draw that? Normally, that would look like this, correct?
Yeah.
Well, we don't have this part to the left. I got to erase that because it only looks like that when x is greater than 0. And we do know what that point is. All of these exponential functions always cross the point 0, 1. In other words, when you plug in 0 for x, 2 to the 0th power is always 1. Any number to the 0th power is 1.
Yeah.
So whenever x is greater than or equal, so that's a solid dot right there, that's my function. Now let's go down to the next one. When x is less than 0, we're in the green domain. Well, let's erase that green domain, but that's where we're going to plot this function. What does this function look like?
It's the absolute value, so it's like a like a V thing or like a
Well, normally it would be. In other words, if it was for all x, it would look like this, correct?
yeah.
But it's not for all x. It's only when
Oh,
x is less
so,
than 0. So,
oh, so it's still on the side.
yeah, so I just erase this side, okay?
Yeah.
And notice that these two functions are not continuous. Do I need an open dot at the origin or a closed dot?
Uh, closed dot.
Open. Why? Because it's less than 0. Notice one thing. If that was a closed dot, that would not pass the vertical line test. So it wouldn't be a function.
Yeah.
This tells you it's a function. So it has to pass the vertical line test. In other words, no matter where I put a vertical line through there, it can only have one y value. Well, what is the y value when x is 0?
0.
No, it's not. It's 1. It's this value right there because that's
Oh,
a closed dot.
uh,
In other words, when x is exactly 0, the y value is the closed dot. It's not the open dot.
yeah.
And that is a function whose domain is all real numbers. X can be anything. But the fact is, it's also not continuous. There is a break right there where the only way I can draw that thing is to lift up my pencil. And that's the classical layman's definition for continuity, is if you have to lift up your pencil to draw it, then it is not continuous. And I have to lift up my pencil right there. Because coming down from the left, I go all the way to 0, but then coming off on the right, I start at 1. Okay?
Yeah.
All right. Scroll down a little bit here. Is this everything on this page?
Yeah, that's really all I have for you today.
Okay, that's fine. That's no problem. Are you on spring break this week or not?
No, I'm just back from spring
Oh,
break.
you had it last week? Okay. All right. Well, we can end there. I wasted about 15 minutes of your time, so I'll just charge you for a half an hour tonight,
Oh, okay.
just because I had to reboot my computer. But I'm glad I did because it solved all the problems, didn't it?
Yeah.
I think it did. We had good audio, and you were able to see what I was writing in pretty much real time. And that's what you have to be able to do. If it's a 2-second delay, it sucks.
Yeah.
So, all right, Blake, I will talk to you next time.
Alrighty, thank you.
All right, bye-bye.